Hello and welcome. This is a bit of a special deep dive today.
hmm
If you happen to be learning English and you're interested in tech topics, well, you've landed in the right spot.
Yeah, definitely.
We're going to chat about some technical concepts, but we'll try and keep the English fairly straightforward, so hopefully you can learn about both things together.
Sounds like a plan.
Okay, so today we're looking at what comes after you've got the basics of Helm down.
Right. Helm, the package manager for Kubernetes. Super fundamental.
Exactly. So you probably already know about things like Helm charts, releases, maybe repositories.
The core stuff, yeah.
Our source for this is a document titled A Helmio, basically, a guide mapping out what developers should look into next with Helm,
A roadmap for leveling up your Helm skills.
pretty much. Our mission here is to figure out, okay, what are those really key next steps once you've moved past Helm 101?
Let's dive in. There's definitely more to explore beyond the basics. That document lays out a good path.
All right, so first up, the document highlights advanced Helm chart templating. Sounds potentially tricky. Why is this the first step up?
Well, it sounds complicated, but it's really about power and flexibility. Advanced templating lets you build charts that are way more dynamic, reusable,
Just
more powerful, really.
more powerful than just swapping out values in a values.yaml file.
Oh, much more. Instead of just basic variable substitution, you start adding actual logic into your templates.
Yeah.
This means one chart can handle lots of different scenarios.
Right. Fewer charts to maintain, maybe?
Exactly. That's a huge benefit. Less redundancy, more adaptability. That's the core idea.
Okay, I'm following. The document mentions loops and conditionals. What are those in the Helm world?
So these are programming concepts, basically, that you can use inside your Helm templates. Think range loops.
Range, like iterating over something?
Precisely. You can loop over a list of items defined in your values.yaml. Imagine you need to create, I don't know, a whole bunch of environment variables in a config map. Instead of writing out each one, you use range to loop through a list in your values and generate them dynamically.
Ah, neat. And conditionals, like if this, then that.
Yep, exactly that.
Yeah.
Using if, else, and else if, you can make parts of your chart optional. Maybe you only want to create a Kubernetes service if a certain value is set to true.
Ah, I see. So maybe I only enable an ingress resource in my production environment, but not in development, using the same chart.
Perfect example.
Yeah.
You control it all through your values.yaml file without needing completely separate chart versions. It makes the chart adapt.
That sounds way more manageable than juggling slightly different charts for everything.
It really is. Reduces that repetition, the redundancy, and boosts adaptability. It's a big step up from basic templating. The strategic advantage is managing diversity with uniformity, if that makes sense.
Yeah, it does. Okay, next thing listed, helper templates. That sounds inherently useful.
They definitely are. Helper templates live in a special file, usually called helpers.tpl. Think of them as reusable chunks of template code.
Like functions.
Kind of, yeah. Little snippets of logic or configuration that you find yourself using in multiple places within your chart templates.
Okay.
So you define it once in helpers.tpl, and then you use the include function to pull it into your deployments, services, wherever you need it.
What's a common use case for that?
Oh, standard labels are a classic one. You probably want the same set of labels on all your Kubernetes resources, right?
Yeah, usually. For tracking and selection.
Exactly. So instead of copy-pasting those labels into every single resource template file,
You define them once in a helper.
you got it. Define them in a helper template, include it everywhere. Then, if you need to change a label later, you change it in one place.
Nice. That follows that DRY principle, right? Don't repeat yourself.
Precisely. Makes charts much easier to read, maintain, and less error-prone. Cleaner code, basically.
Makes total sense.
Mhm.
All right, moving on. The TPL function. This one sounds a bit more obscure. TPL. What's that about?
Yeah, TPL is interesting. It's quite powerful. It essentially lets you treat a string value as if it were a template itself, and then render it.
Huh. Treat a string as a template.
Yeah. So imagine you have a string, maybe coming from your values.yaml file, or maybe read from an external config file, and that string contains Helm template syntax, like values.sum setting.
Yeah.
Normally, Helm would just output that string literally. But if you pass that string through the TPL function, Helm will actually process the template syntax within that string.
Whoa. Okay, why would I need that?
It's super useful for complex configurations. Maybe you want to allow users to provide snippets of configuration as values. Or perhaps you're templating an external file, like a complex Nginx config, and you want Helm values injected into it.
So I could have like a block of configuration text in my values.yaml and use TPL to inject other values into that block.
Exactly. It adds another layer of dynamic capability.
Hmm.
You're not just templating the main YAML structure, you're templating content within that structure. It gives you deeper dynamic control.
Okay, that's advanced. And the last bit under advanced templating is post-rendering. What's happening after the rendering?
Right. So post-rendering is a mechanism that lets you modify the Kubernetes manifest files that Helm generates after Helm has finished its templating process, but before those manifests actually get sent to the Kubernetes API server.
A final modification step.
Exactly. A last chance to tweak things.
Why would I need to do that? If Helm already generated it, why change it?
Good question. Several reasons. Maybe you want to integrate with another tool, like Customize, to apply some standard patches or overlays across all your deployments, regardless of the chart.
Ah, okay. So you could layer Customize on top of Helm?
Yep. Or maybe you need to inject a sidecar container, like a security agent or a service mesh proxy, into pods defined by the chart, but you don't want to modify the original chart itself.
Right. Sometimes you can or don't want to touch the upstream chart.
Exactly. Or you could perform some really custom validation checks on the final manifest before they hit the cluster.
How does it work mechanically? How do I do post-rendering?
Helm provides a post-renderer command line flag for commands like install, upgrade, and template. You point this flag to an executable script or program.
Okay.
Helm pipes the rendered manifest to that script. The script does its modifications, and then pipes the modified manifests back out, which Helm then uses.
So I need a separate script.
Yeah, you need something that can read YAML from standard input, transform it, and write YAML to standard output. For more complex stuff, the Helm Go SDK offers a post-renderer interface for building custom integrations.
So the big idea is extending Helm's output without modifying the input chart.
Exactly. It's an extension point, powerful for integrating with other ecosystem tools or enforcing specific organizational policies.
Okay, that covers advanced templating pretty well. Now, let's shift gears. What about actions during the deployment lifecycle? The document mentions leveraging Helm hooks.
Ah, hooks. Yeah, these are really handy. Helm hooks let you run specific Kubernetes resources, like jobs or pods, at defined points in a release's lifecycle.
Points like before installing, after upgrading, stuff like that.
Exactly. There are hooks for pre-install, post-install, pre-upgrade, post-upgrade, pre-delete, post-delete, and even for rollbacks, pre-rollback, post-rollback, plus a test hook.
So you can automate tasks around the actual application deployment?
Precisely. You define these hooks using a special annotation, helm.shook, inside a standard Kubernetes manifest file within your chart.
What kinds of tasks would you typically use hooks for?
Oh, lots of things. Database schema migrations are a very common one. Run a job to update the database schema after an application upgrade, post-upgrade.
Makes sense?
Or maybe loading initial seed data, post-install, running some health checks before an upgrade proceeds, pre-upgrade, cleaning up external resources after deletion, post-delete, or backing up data before deletion, pre-delete.
So these are actual Kubernetes objects, like a job, that just have a special label telling Helm when to run them.
That's basically it, yeah. The annotation tells Helm it's a hook and when in the lifecycle to execute it.
Can you control the order if you have multiple hooks for the same point, like multiple post-install jobs?
Yep. There's another annotation, helm.shookweight, which takes a number. Hooks run in ascending order of their weight. So a hook with weight -5 runs before one with weight 0, which runs before one with weight 10.
Ah, so you can sequence things properly, like create a database schema before loading data into it if both were post-install hooks.
Exactly that kind of scenario. Order can be critical. And there's also helm.shookdelete policy, which tells Helm what to do with the hook resource itself after it runs. Should Helm delete it? Only if it succeeds. Or leave it around.
Okay, gives you control over the cleanup too.
Right. Hooks are powerful for automating those critical lifecycle tasks, making deployments smoother.
Any downsides or things to watch out for?
Well, they can add complexity if overused. Sometimes an init container within your main application's pod might be a simpler way to handle initialization tasks rather than a pre-install hook job. Also, be aware that the exact behavior can sometimes subtly differ depending on how Helm is run, like via CLI versus Argo CD, though that's becoming less common.
Good points. Okay, next up. Structuring complex applications with Helm subcharts, charts within charts.
Yeah, that's the basic idea. Subcharts or chart dependencies let you bundle multiple charts together. You have a main parent chart, and it depends on one or more child charts.
When would this be useful?
Think of a complex application that's composed of multiple services. Maybe your web application needs a database and a caching layer.
Okay.
Instead of managing 3 separate Helm releases, you could create a parent chart for the whole application. Then, you'd list the official database chart, like PostgreSQL, and the caching chart, like Redis, as dependencies, as subcharts.
So deploying the parent chart automatically deploys the database and cache too.
Exactly. It manages the dependencies. You define these dependencies in the chart.yaml file of the parent chart, specifying the subchart's name, version, and often the repository where it to be found.
How do you configure the subcharts? Do they just use their default settings?
You can configure them right from the parent chart's values.yaml file. The structure usually mirrors the subchart names. So if your subchart is named PostgreSQL, you'd have a PostgreSQL.section in your parent's values.yaml, where you can override any of the PostgreSQL chart's default values.
Ah, so the parent controls the configuration of the children.
Mostly, yes. There's also a concept of global values, which are values defined at the top level in the parent chart that can be accessed by all subcharts, which is useful for sharing common settings like image registries or domain names.
Seems like a really structured way to handle apps with multiple components.
It is. It promotes modularity and reusability. You can package a whole stack together. Sometimes people create umbrella charts that don't deploy anything themselves, but just group together several other application charts as dependencies.
Good way to manage complexity. Any potential pitfalls?
Just that deep nesting can sometimes become confusing to manage and debug. And for managing dependencies across many independent Helm releases, rather than bundling them into one parent, other tools might come into play.
Which neatly brings us to the next topic, Introduction to Helmfile. You mentioned it as an alternative?
Sort of, yeah. Helmfile isn't part of Helm itself. It's a separate popular tool that wraps around Helm. Its main purpose is to help you declaratively manage multiple Helm releases, often across different environments.
Declaratively, like infrastructure as code.
Exactly like that. Think Terraform, but for Helm releases. Or maybe Docker Compose, but for orchestrating Helm charts. You write a helmfile.yaml file describing what releases you want, with what configurations in which environments, and Helmfile figures out how to make it happen using the underlying Helm commands.
So what's the big advantage over just running Helm install or Helm upgrade commands myself, maybe in a script?
Consistency, reproducibility, and environment management are key.
Yeah.
Helm itself mainly focuses on managing one release at a time. Helmfile lets you define your entire application landscape, maybe dozens of microservices, each with its own chart in one file. And it makes managing environment-specific configurations much easier. You can define base values and then overlay specific values for development, staging, production, etc., all within the Helm file structure. It's great for CI/CD.
So that helmfile.yaml file, what does it contain?
Typically, sections like repositories, where to find charts, releases, listing each application you want to deploy, its chart, version, values, files, etc., and often environments to define those different configurations for dev, staging, prod. You can also set values directly in the file.
Does it have other features?
Oh yeah. It supports labeling releases for partial apply asyncs, templating within the Helm file itself, environment variables, and integration with secrets management tools like HashiCorp Vault or Mozilla SOPS via plugins like Helm Secrets.
So if I've got a complex system with many services, potentially different versions or configs in different environments, Helmfile helps orchestrate all that.
Absolutely. It provides that higher level of orchestration. You run commands like Helmfile sync or Helmfile apply, and it figures out all the necessary Helm upgrade install commands with the right values for the target environment. Helmfile diff is also super useful to see what would change.
So Helm for managing the individual package, Helmfile for managing fleets of packages.
That's a pretty good way to put it, yeah. Simplifies managing complex Kubernetes application landscapes deployed via Helm.
Makes sense. Okay, shifting focus, again, a really critical area. Securing Kubernetes deployments with Helm. How do we approach security with Helm?
It's super important. Helm makes deploying easy, but that ease doesn't automatically mean secure. You need to be mindful. Potential risks include charts having insecure default configurations, secrets being handled poorly, or vulnerabilities within the chart's dependencies or the application image itself.
What are the key best practices the document suggests?
Several things. First, role-based access control, or RBAC. Limit what Helm itself, or the tool running Helm like a CI/CD pipeline, is allowed to do in the cluster. Least privilege applies here.
Okay, limit Helm's power.
Right, and also limit the permissions of the applications deployed by Helm. The chart should ideally create service accounts with minimal necessary permissions.
Makes sense. What about secrets? Passwords, API keys?
Huge one. Never, ever hard code secrets directly in your values.yam or templates. Use proper Kubernetes secrets. Even better, integrate with external secret management systems. Tools like Helm Secrets, which works with SOPS, Vault, etc., or operators like the External Secrets Operator are fantastic here. They allow you to store secrets securely outside the cluster or Git repo and inject them at deploy time.
So keep secrets out of the chart and values files. Got it.
Also, be careful where you get your charts from. Use trusted repositories. Verify chart integrity if possible, maybe using signed charts, although adoption there is still growing.
Good point. Source matters.
And harden your chart values. Don't rely on potentially insecure default values from upstream charts if you can avoid it. Set secure values, especially for things like passwords or resource request limits, using environment-specific value files. Basically, review and configure charts carefully for your specific security needs.
Are there tools to help find issues?
Definitely. Vulnerability scanners like Trivy or SNCC can scan not just container images, but also Helm charts themselves for known CVEs and misconfigurations. Integrating these scans into your CI/CD pipeline is a great practice.
So embedding security checks right into the workflow.
Yeah. Security shouldn't be an afterthought. It needs to be part of the whole Helm deployment lifecycle.
Absolutely. Which leads nicely into the next topic. Integrating Helm into CI/CD pipelines. How does Helm fit into automated workflows?
It fits very naturally, actually. Using Helm within a CI/CD pipeline continuous integration, continuous delivery is pretty standard practice for automating Kubernetes deployments. The benefits are consistency, speed, and reliability.
What CI/CD tools work well with Helm?
Pretty much all the major ones. The document mentions GitHub Actions, Jenkins, and GitLab CI specifically. You can easily script Helm commands, lint, package push, upgrade test, etc., within the pipeline definitions of these tools.
So the pipeline would say, build an image, package a Helm chart with the new image tag, and then deploy it.
Exactly. A common flow might be code change triggers pipeline build and push container image update Helm chart version and image tag, run Helm lint, and maybe some chart unit tests. Deploy to a staging environment using Helm upgrade install, run Helm tests, Helm test, potentially wait for approval, deploy to production.
What are some best practices when doing this?
Versioning is crucial. Version your charts properly. Semver is common, alongside your application versions. Always perform dry runs, Helm upgrade dry run, and diffs, Helm diff upgrade, in the pipeline before applying changes to a live environment so you can see what's about to happen.
Good safety checks.
Definitely. Implement solid rollback strategies. Helm's history and rollback features help here, but your pipeline should be designed to handle failures gracefully. And as we just discussed, integrate security scanning images and charts right into the pipeline.
Makes sense. The document also mentions GitOps.
Yeah, briefly. GitOps tools like Argo CD or Flux CD often work really well with Helm. In a GitOps model, your Git repository becomes the source of truth for your desired state, including which Helm charts and versions should be deployed with which configurations. The GitOps tool then automatically synchronizes the cluster state to match what's defined in Git, often by running Helm commands under the hood.
So CI/CD builds the artifacts, image, chart, and GitOps handles the deployment based on changes in Git.
That's a common pattern, yes. It provides a really robust, declarative way to manage deployments. Integrating Helm into CI/CD, whether directly scripted or via GitOps, is key to efficient and reliable Kubernetes application delivery.
Okay, one last major area, ensuring reliability, comprehensive testing strategies for Helm charts. We need to make sure these charts actually work right.
Absolutely essential. A chart might look fine, it might even install, but does it deploy your application correctly? Does the app function? Testing is crucial for reliability.
What kinds of testing should we be doing for Helm charts?
The document outlines a few levels. First is linting.
Like code linting.
Yeah, Helm lint checks for syntax errors, potential issues, and adherence to best practices in your chart structure and templates. Tools like Terrain, chart testing, often bundle linting too. It's a basic first check.
Okay, what's next?
Unit testing. This focuses on testing the template logic itself. There are plugins like Helm Unit Assist that let you provide different sets of values and assert that the generated Kubernetes manifests look exactly how you expect them to without needing a live cluster.
So checking if the templates produce the right YAML for given inputs.
Exactly. Then you have integration testing. This is where you actually deploy the chart to a real or temporary Kubernetes cluster, maybe using tools like Kind, Kubernetes and Docker, or Teratist, and then you verify that the deployed resources are running correctly.
Checking if it works in a real environment.
Right. And finally, smoke testing. These are basic checks run after deployment succeeds to make sure the application is minimally functional. Is the web server responding? Can it connect to the database?
Can I automate some of these tests using Helm itself?
Yes. Helm has built-in support for tests using that same hook mechanism we talked about earlier. You can define Kubernetes jobs or pods with the annotation helm.shook.test.
Ah, the test hook.
Right. When you run Helm test release name, Helm will execute these test resources. They typically contain scripts or applications that verify the deployed release is working as expected. It's great for running integration or smoke tests as part of your deployment process or CI/CD pipeline.
So testing involves checking the chart code, the template output, and the running application.
That's the ideal, yeah. A
Yep.
multi-layered approach. Linting catches basic errors, unit tests verify template logic, integration Helm tests verify deployment in a cluster, and smoke tests give basic operational confidence. Comprehensive testing is key to ensure your Helm-deployed applications are stable and reliable.
Wow, okay. That was a lot to cover, but really useful stuff beyond just Helm install my chart.
Definitely. We went through advanced templating with loops, conditionals, helpers, TPL, and post-rendering, then hooks for lifecycle automation, subcharts for managing dependencies.
Right, and Helmfile for orchestrating multiple releases, plus the crucial aspects of security, fitting Helm into CI/CD, and robust testing strategies.
It shows how much depth there is to Helm and its ecosystem once you move past the initial learning curve.
It really does. Feels like the Kubernetes world is always evolving, always more to learn.
That's the fun of it, isn't it? Continuous learning is key. But mastering these advanced Helm concepts really does give you, the developer or operator, a significant advantage in building and managing modern cloud-native applications effectively.
So, a good takeaway for you listening might be to pick one of these areas that seems most relevant to your current challenges and start exploring it further.
Yeah, experiment. Try out helper templates, set up a basic hook, look into Helmfile if you're managing multiple services. See how these tools can improve your workflow.
Excellent advice. Well, thank you for joining us on this deep dive today.
My pleasure.
And thank you all for listening.